All right, so today's notes will be over proportionality and non-proportionality relationships. Once again, we're still working with those unit rates, ratios, and rates here. So it's very important to know the how to find a ratio and those unit rates. So starting off with what a proportional relationship is here. So if it is proportional, that means that if the ratios or rates of the two quantities are equal, then the quantities are proportional. So once again, if I get my unit rate or my ratio, if they are equal to each other or my whole table, that means that they are proportional. Now, in the case, the opposite, if the ratios and rates of two quantities are not equal, then those quantities are non-proportional. Okay, so looking at an example, let's say I look, Eric and Lucy ran 20 minutes each on the treadmill at the gym. The table below shows the number of calories each has burned after 5-minute intervals. Complete each table, determine the relationship. Now, the reason we didn't really go over tables and how to find the unit rate for that is because I was just going to do it all at once, which is here. Okay, so if I look at these two tables that I have right here, one represents Eric, one represents Lucy. Okay, I want to make sure that I can find the rate, the unit rate for this. Now, how I do that is I always want to make sure that I divide correctly, because as we kind of caught on, all we are really doing here is just making sure that we are dividing correctly. Now, the biggest thing when we divide is we want to make sure that we divide y over x. When I divide y over x, I also have to make sure that I know, hey, in my table, which one is x and which one is y. Okay, so on the left side, you will always have your x coordinates. On the right side of a table, you will always have your y coordinates. So what we're doing here is we're just setting our numbers in this formula that I just gave you every single time to divide. Okay, so if I look first, I have y. My first y value in the first row is 70, so that goes to the top, over my x value in that row is 5, so I put it at the bottom. When I divide 70 divided by 5, I do get 14, and my labels will go in that same order as well. Since I went y first, it's calories per, and then our time. Now I got to make sure I look at the unit that we're in, which is minutes. So I put minutes. Okay. Now, that's how you find a rate or unit rate. So in a question, if it asks you to find the just the unit rate, I just have to pick a row and do that. Okay. Now, if it's asking for proportionality, which is what the definitions we just got at the top. Okay. What we have to do here is we actually have to find the rate for every single row that we have in our table. Okay, so we're going to set up the exact same way that we just did every single time. So if I look at my second row right here, okay, remember it's y over x. My y value is the calories, which is 140, over our x value, which is 10. So when I divide 140 divided by 10, I get, once again, 14 calories per minute. Moving on to our next row, which is 15 and 210. I want to make sure that my y value is at the top, so I put 210 at the top. And at the bottom, I put my x value, which is a 15. When I divide these two numbers, I once again also get 14 calories per minute. And for our last row, once again, we want to make sure that we put our y over our x. So when I have our y, I have 280, because that's in our y value, over our x value, which is 20. So now I have 280 divided by 20, and that gives me 14 calories per minute. Okay. Now, what makes this proportional or non-proportional? Okay. What makes this proportional or non-proportional is our rates. Our rates all have to equal the same thing throughout our table. If our rates do not equal the same thing, it is non-proportional. So if I look, I have 14 here, I have 14 here as a unit rate, 14 again, and 14 again. Because they do all equal the same thing, that means that we do have a proportional relationship here. So when I go to the bottom and look for Eric's information, what I'm going to write here is the calories burned by Eric is proportional to the time because the ratio and you can pick any ratio that we have at the top. And I'm going to go ahead and pick 70 to 5. Or sorry, we actually don't have to do that. Because the ratio are all equal to each other. Okay, so now moving on to Lucy, we're going to do the exact same thing. In order for us to find the unit rate, we want to make sure that we do y over x. Our x value is always time, or on the left side, and our y values are always on the right side. So I'm going to go row by row. First, I want to go with y, because that's what goes on the top according to my formula, over the x value, which is 5 in this row. When I do 45 divided by 5, I do get 9, and my label is still the same, calories per minute. Moving on to the second row, I have 90 as my y, so I put that at the top, divided by my x, which is 10. 90 divided by 10 gives me 9. So I once again get 9 calories per minute. Moving on to our next one, our y value here is 120 over our x value here, which is 15. So 120 divided by the 15 gives me 8 calories per minute. Okay, now, just at this moment, I can see that I have a completely different number. That is not equal to the 9 that I have to the rest. So I know, since I have at least one number that is different, one unit rate that is different to all the other ones, that makes this non-proportional. Okay, I can keep going to see if I get any other different numbers, but even if it's just one number, that makes it non-proportional. They all have to be the same, and if you have one that is not, it is non-proportional. So I'm going to go to the bottom, and for Lucy's, I'm going to say the calories burned by Lucy is non-proportional to the time because the ratio of, and remember we go y to x, so I have 120 to 15 is not equal to the rest. All right, so that is how we find for proportionality or non-proportionality. So just looking at this one, we're just going to determine yes or no. And once again, we want to make sure that we do y over x. Now, when I have a table that goes horizontally like this, the x will always be at the top and the y will always be at the bottom. So all we're doing is dividing. Once again, we're just finding that rate, and all we have to do is divide. So when I look at this table, my formula is y over x. For the first column that I have right here, I would have to do 24 divided by 1. 24 divided by 1 does give me 24. So that means in order for this to be proportional, all the other rows have to equal 24. Or sorry, the columns. So now looking at the second column, I have 45, because once again, it's y over x, 45 divided by the 2, and that gives me 22.5. That does not equal 24, so right off the bat, we can see that they're not going to equal the same thing. So my relationship here is no, because we're just determining, is this all going to be proportional or not? Moving on to number 2. Hours worked, which is your x, and money earned, which is your y. Okay, x is at the top, y is always at the bottom when you have horizontal tables. So we're going to divide just like we did before. We have y over x, which is 36 divided by 4. 36 divided by 4 is 9. Moving on to our second column. Your y is 72. Your x is 8. 72 divided by 8 is also 9. So I'm going to keep going. Moving on to our third column. Our y here is 90 divided by our x, which is 10. 90 divided by 10 is 9. So far we're so good. I'm going to do it one more time to make sure that all of our numbers equal the same thing. So 135 over 15. 135 divided by 15 does equal 9. Therefore, this is a proportional relationship. So I have yes. Now, it does want us to give us the constant rate here, which is just our unit rate. So what I'm going to do is I'm going to give the answer. So our unit rate here is 9. Do not forget your label. Remember, your label always goes first from y to x. So my y label is money. So I'm going to put $9 per hour. Perfect. All right, so moving on, I'm going to go ahead and skip a few of these. If you guys want to do practice on these, I would recommend you guys to do practice on these, and we can go over them in class. Okay, now for completing the table, what we're going to look at here is when you have to complete the table, they're not going to give you a non-proportional relationship. They're going to give you a proportional relationship. So what you really have to do here is just fill out your y. Okay, now in reality, all we're doing here is we're going to do the opposite of what we just did at the top. Okay, when they give us our whole table, we were able to divide. But this time around, they're not giving us our whole table. So we're going to have to go ahead and do the opposite, which is multiplication. So here it says Ben earns $8.50 per hour bagging groceries at the grocery store. Okay, so that is $8.50 per hour. That per hour means that he's getting paid that $8.50 for just 1 hour. Okay, so when I'm filling out this table here, I got to look at my hours here. I have 4, 8, 10, and 14. What we're going to do here is we are going to multiply. Okay, because I can add them every single time. So I can add 8.50 plus 8.50 plus 8.50 plus 8.50. You can do that, but multiplication would do the exact same thing. So when I take 8.50 times the 4, I will get what my y value equals right here. Okay, and 8.50 times 4 gives you 34. And we do it again over here. I have 8.50 once again times the 8 this time, and that gives me 68. Over here, 8.50 times 10 gives me 85. And lastly, 8.50 times the 14 gives me the 119. So all we're doing is multiplying. So you filled out your table and you are done. Okay, let's do one more. All right, so let's go ahead and do the real estate one, number 10. So it says the real estate office sells 7 homes per month right here. Complete the chart, then determine how many homes they will sell in 2 years. Okay, so this means that every single month they sell 7 homes. So if I look at my table, they want to know how much houses I'm going to sell for 2, how many I'm going to sell for 5, for 8, and for 10. So all I'm doing here is multiplying the 7 to each one of these months. So first up, I have the 2 months. So I'm going to have 7 times 2, which is 14. For 5 months, I multiply 7 times 5, which gives me 35. For 8 months, I have 7 times 8, which gives me 56. And lastly, I have 7 times 10, which is 70. Now, I am done with the chart, but we did have a separate question in this one, and it says determine how many homes they sell in 2 years. Okay, this is in years, and this table is in month. If you thought your answer was going to be 14, that is incorrect because that is just 2 months, and we're talking about years. How many months are in 1 year, and how many months are in 2 years? Now, in 1 year, there's only 12 months. If I think about it, in 2 years, I actually have 24 months. So what we're going to do is we're going to convert that 2 years instead and look at it as 24 months. Okay, so in order for me to figure out how many homes I sold in those 24 months or 2 years, I'm going to multiply the 7 times the 24. 7 times 24 is equal to 168. So they're going to sell 168 houses. Okay.